Hi guys, and welcome back to Aisha's Academy. So today I'm going to be going through paper 2 of the AQA November 2018 higher series. I've done paper 1, which is already on my channel. I'll put it in the description box down below if you want to check that out. So yeah, let's crack on into it. So going on to question 1, let me just zoom in. It says, what does A and then that sign B represent in probability of A sign B? So that sign means and. So when you see it up like a U shape, it means or. When you see it down, it means and. And how I like to remember it is because and has an N in the middle, so and. So then what it basically now means is the probability of having an A and a B. So if I quickly draw a sketch of a Venn diagram, A, B, so probability of A and B just strictly would be the middle part of just A and B. So that's fine. If it was A or B, then it could be A or B or both, but that is not the case. All right, so moving on to question 2, it says P is 4, 9, and Q is 2 minus 2, 1, and it wants us to work out the midpoint of PQ. So in order to work out the midpoint, to work out the x value of the midpoint, it's x2 plus x1 divided by 2. And then the y value is x2 plus y2, plus y2 plus y1 divided by 2. So let's have a look at it. So the two x values added together, so that's going to be 4 plus minus 2. Remember, if you've got a positive and negative next to each other, it's going to become negative. So 4 minus 2 is 2, divided by 2 is 1. And then the two y's added together, so let's have a look. So we've got 1 plus 9, and then 1 plus 9 is 10, divided by 2 is 5. So the one that we want is that one. And then it says, for question 3, which of these is a geometric progression, and circle your answer. So in terms of geometric progression, we want to see a constant number being multiplied each time. So let's have a look at all of them. Okay, so here you could times by 3, but here you times by 2, and here it's just not constant, so no, it's definitely not that one. Let's look here, so it's going up in odds, so it's being added by the same number each time, but not multiplied. So they're all being added by 2, so it's not that one. So now we're left with these two. Here it looks like a sequence of squared numbers, so we've got squareds, which could be an option, but they're not being multiplied by a specific number each time, so no. And here we can see if we multiply by 3 each time, that works. So the one with geometric progression would be this one. Okay, let's have a look at question 4. So it says the bearing of A from B is 310 degrees. Circle the bearing of B from A. So again, I like to draw things out to help visualize it. So I'm going to draw a dot. So because it's the bearing from B first, I'm going to draw my B, draw my line up, and then go round to my approximate. Obviously, it's not drawn to scale, but roughly that would be 310 degrees. So I know A would be anywhere along this line. So if I put A here and the arrow up for bearings. Okay, so if that's 310 degrees, then we know a circle is made up of 360. So to work out that inner part, it would be 360 minus 310, which would be 50 degrees. So that bit would be 50. So now this angle here, because we're working out the bearing of B from A, so the bearing of B from A would be from the north of A to where it hits that line. So luckily we can see a kind of C angle has been formed. And in terms of C angle supplementary angles, we know the two angles within would add up to, so if I call them X and Y, they add up to 180 degrees. So in order to work out this red angle, it would be 180 degrees minus 50 degrees, which is 130 degrees. So let's go on to question 5. So in terms of question 5, it says circle has circumference C and diameter D. I do have a video on circle circumference and areas of the circles in the description box down below. So it says, what value does the constant K represent? Well, let's have a look at it. So we know that the equation for working out the circumference of a circle is here in terms of circumference equals KD. But then we know that it's actually circumference equals pi times the diameter, or if it was to do a radius, it would be 2 pi r. So that means pi must be k. And then moving on to question 6, it says, here is some information about 20 trains leaving the station. It wants us to work out an estimate of the mean number of minutes late. So the first things first is we're going to write down the midpoint. So remember, the midpoint is the midpoint of the class interval. So the first one would be 2.5, 7.5, 12.5, and so on. Then now, in order to work out the frequency, so the mean number, the first thing is that we need to work out the actual grand total, like the total number of trains. So in order for us to do that, we need to multiply the frequency of each class interval by the midpoint. So this one's 0, so it's not really going to give us anything at all. So I'm going to put this column as the midpoint times the frequency. So the first one, again, because this is a calculated paper, you could just put all of these calculations into your calculator. So the first one, 12 times 2.5 should give you 30. Then the next one should give you an answer of 52.5. And the next one should give you an answer of 12.5. Again, the last column has a 0, so that's not going to give us any answer. So add together all the answers that you have so far, and you get a total of 95. So now that we have our total number of trains, in order to work out the mean number, remember mean is your total number, which is 95, divided by the total number of trains you have. So that would be here. So your mean is your answer from this column divided by your answer from this column. So first of all, we're going to add our total there, and that's going to be the 12 plus 7 plus 1, which will give you an answer of 20 if you put that into your calculator. So 95 divided by 20 into your calculator should give you an answer of 4.75. And I hope that made sense. So I'll put that there, 4.75. Okay, so moving on to part B, it's now the follow-up of this question. So it's the same information in terms of number of trains that are late. However, it now goes on to say that the station manager works out an estimate of the mean using this information. And how does his estimate compare with the answer in part A? So if you have a look, the table here is more, they've basically shortened the class intervals, whereas here, the class intervals are longer. So if we have a look, if we roughly were to work out the midpoint here, so if we quickly worked it out, so the midpoint of each class interval here would be 1, 3, 5, 7, 9, 11, and then the M times F column, that would be 12 for the first one, that's just 0, 35, 0, 0, 11. Add them all together into your calculator. So that would be 12 plus 35 plus 11, which give you an answer of 58. And then our total here is still the same as 20 as before. So then our grand total of 58 divided by 20 would give you an answer of, in your calculator, 2.9. And if we have a look at our estimate mean of lateness in minutes of 2.9 compared to the 4.75, we can happily say that this part B is lower than part A. Okay. And then having a look at question 7, it says work out the values of A and B in this identity. So we can see that we've got factorized brackets. So the first thing that we're going to do is on the information given on the left-hand side of the sign, the 3 line sign, we are going to expand the brackets. So that's going to give us 35x plus 40 plus 6x plus 3b is equivalent to that. Then we're going to simplify. So 3x plus 6x is 41x. And then you've got 4b plus, well, you've got 40 plus 3b. So plus 40 plus 3b is equivalent to ax plus 13. So that means because our x, our 41x, and our ax, we can happily say that a is equal to 41. But now we need to work out what b is. So if we look at b, it's 40 plus 3b equal to 13. So now we're going to rearrange this formula to work out what b is. So if we take away 40 from both sides, 3b is equal to 27. And then if we divide minus 27, and then if we divide by 3 on both sides, b is equivalent to negative 9. So we can happily say that b is equal to minus 9. Okay, having a look at question 8. So it says we've got two identical quarter circles that are cut from a rectangle as shown. So it says it wants us to work out the shaded area. So first things first is that it's given us one of the lengths, which is 12 centimeters. We can see that the two circles touch each other nicely. So that 12 centimeters can be split up into 6 centimeters and 6 centimeters. And because this is a quarter of a circle, that's the center and that's an edge of the circle. We know that the distance from the center of a circle to the circumference is known as our radius. So what we can do is we can work out, first of all, since we're working out shaded area, we can work out the area of the quarter circles. So the equation for the area of a circle is pi r squared. So that would be pi times 6 squared, so 36 pi. But because it's a quarter of the circle, a quarter we divide by 4 to work out the area of a quarter, which would be 9 pi. So this area is 9 pi, and because they're identical, that would be 9 pi as well. So again, because we know that the radius, because that's the center of that circle, we know the radius is 6 centimeters, that's 6 centimeters as well. So we can work out the area of the rectangle. So the area of the rectangle is length times width, which would be 12 times 6, which would be 72 centimeters. So in order to work out the area of the shaded squared, in order to work out the area of the shaded region, put centimeters squared there as well, to work out the area of the shaded region, it would be the 72 centimeters squared minus the 9 pi and minus the 9 pi centimeters squared. But because they're both 9 pi, you can add them together to make 18 pi. So in your calculator, put 72 minus 18 pi. And your answer from that should give you 72 minus 18 pi. You should get something around 15.4 centimeters squared, or you could leave your answer as 54 pi as well. Either way, they wouldn't penalize you. Okay, so going on to question 9. So question 9 says the diagram shows the position of a tap that when it's off and when it's fully on. So when it's fully on, it's 180 degrees, which we can see in this image here. It says that when the tap is fully on, it goes out at a rate of 14 liters per minute. So it says the rate at which water flows out is in direct proportion to the angle turn. So it says now the tap is turned 135 degrees, and it says that the water flows into a tank with a capacity of 79.8 liters, and it's basically asking us, will it take less than 7.5 minutes to fill the tank? So there's several ways of working this out. There's so many different methods. So I'm going to go through one way, and then after I explain the different ways you could have worked this out. So the first thing is that we want to work out the amount of water that would come out of the tap per minute when it's at 135 degrees. So we know if at 180 degrees, its rate is 14 liters per minute, to work out 135 degrees, I would do 14 divided by 180. That would tell me its rate at 1 degree, and then times by 135. That would give me an answer all in my calculator of 10.5 liters per minute. So I know that when it's at 135 degrees, that's its rate. So now I want to see how long it would take to fill up 79.8 liters when this is my rate. So what I can do is I'm going to do 79.8 divided by 10.5. That will tell me how many minutes it will take to fill up that tank. Put that into my calculator. That gives me an answer of 7.6. We know that 7.5 minutes is equal to 7.5 minutes. So because it takes 7.6 minutes, then the answer is no, because 7.6 is more than 7.5. Another way that you could have worked it out is you could have done the 7.5 times by 10.5 and see how many liters would have been filled in 7.5 minutes. And if you're seeing that capacity is less than 79.8, that's another way of comparing it. So you could have done the method of comparing it in terms of the time, or comparing it in terms of the actual liters there, or comparing it in terms of the rate as well. There's so many different methods, and the mark scheme allows for all those different types of methods. Okay, so moving on to question 10, it now says this is triangle is an equilateral triangle, and it's basically asking if the perimeter of the triangle is greater than 1 meter. So first of all, we know that the lengths are in centimeters. So we know the conversion of 1 meter to centimeters is 100 centimeters. So I need to make sure that in order for this statement to be correct, the total needs to be above 100 centimeters. So in order to work it out, we need to work out what x is. So with an equilateral triangle, all the sides are the same, right? So that means this side here is equal to this side, which is equal to this side. So I'm only going to make two of the sides equal to each other just to work out what x is. So I'm going to use the first two, so this one and this one. So 6x minus 10 is equal to, so that would be equal to 4x plus 5. Then we're going to bring the x's together and then bring the numbers together. So that would be 2x is equal to 15. So then divide by 2 on both sides. X would be equal to 7.5. So now we know what x is. We're going to work out what each side is. So I'll just substitute into one of them. Let's say into this one. So 4 times 7.5 plus 5. Put that into your calculator. That should give you an answer of 35. Because it's equilateral, they should all be equal to 35. If you want to double check that, that is fine. So then, because they're all 35, 35 times 3, because there's 3 sides on a triangle, put that into your calculator, you get 105 centimeters. And because 105 centimeters is greater than 100, therefore, yes, the perimeter of the triangle is more than 1 meter. So let's go have a look at question 11. So it says the approximation for the value of pi is given by this long equation. And it wants us to use our calculator to show that the approximation is within 0.1 of 3.14. So what that means is it basically, the answer that we should get in our calculator, if it's within 0.1, it should either be between 3.04 to 3.24, any between that range, because that's between 0.1 of 3.14. So if you put this all into your calculator exactly how it's written, you should get an answer of about 3.041 and so on. And as we can see, if we did 3.14 take away 0.1 to work out the lower bound of that range, it would be 3.04, as I mentioned previously. And so we can see that because we got an answer of 3.041, that is an approximate of 3.04, which therefore shows that this value is within the range. And then question 12 is to do with standard form. So there is a way of working out standard form without a calculator, because it's a calculator paper, and usually without a calculator it wouldn't involve so many decimals. So literally I would put it into the calculator as it's shown, which is 9.12 times 10 to the power of 10 divided by 3.2 times 10 to the power of 4. And you should come out with an answer of, because you're writing it in standard form, your answer from your calculator would probably come out like this, which is 2,850,800. But then to write it in standard form, that would be, so remember in standard form, the first number must range between 1 and 9.99. And so fit in the decimal place here to make it 2.85 fits within that range. Then to work out what the power is, look at how many spaces are after that decimal place, which is 6. So 2.85 times 10 to the 6. Okay, having a look at question 13. So it says Ashraf is going to put boxes into a crate. So it's now giving us the dimensions of the crate. So I'm just going to sketch a quick cuboid. So 2.5 meters, 2 meters, 1.2 meters. And then it says that each box is a cube length of. So imagine this is within that. So each dimension is 50 centimeters, but 50 centimeters in meters is 0.5 meters. So long story short, what Ashraf has done, right, is that he is now claiming that you can put 48 boxes in the crate, because if you divide the volume of the crate by the volume of one box, it gives you 48. Yes, doing 6 divided by 0.125 does give you an answer of 48. However, this does not mean that you can fit 48 boxes within the crate, because I'll give you for an example. So if we look along this part where we know one of the lengths is 2.5, so if we did 2.5 divided by 0.5 in your calculator, you should get 5. So there you could fit around 5. Then if you put into your calculator 2 divided by 0.5, see how many you can fit along there, it'll be 4. 2, 3, 4. Now the 1.2, if you did 1.2 divided by 0.5, you get an answer of 2.4. And so you can't fit 0.4 of a box. So really the only ones that you can fit up of that height is 2 rows. So because that's to the nearest whole number. So if you did 5 times the 4 times the 2, since you can only fit the 2, into your calculator, that means that Ashraf can only fit 40 boxes in the crate, not 48 boxes. Because we have to remember, with volume, it all depends on the shape of it. Even though, yes, the total volume, he could probably fit in terms of the total volume, but then you can't separate the box out to now make it fit the volume. So you can never really do a volume divided by a volume, because the dimensions of the shape really matter in terms of how much you can actually fit in. Okay, so looking at question 14, it says the cross-section of a prism has n number of sides. So it says circle the expression for the number of edges of a prism. So of any prism, to work out the number of edges, it's always 3 times the number of sides. And so it's going to be 3n. Then question 15 says the volume of a medal is 45 centimeters cubed. The medal is made from copper and tin. So it's given us a ratio of the volume of copper to the volume of tin, which is 22 to 3. Then it says that it's given us the density of the copper and the density of the tin. So it wants us to work out the mass. So this is all to do with the triangle. Density equals mass of volume, so that's times divide. Okay, so first off, so in order to work this out, what we need to do is we need to work out the volume, the actual volume of copper and tin, and then divide them by each of their densities in order to work out their individual masses and then add the masses together. So in order to work out their volume, the total volume is 45. But we know that it's given us a ratio, so we're going to add the two parts together. So 22 plus 3 would give you 25. So to work out what one part is equal to, we'll do 45 divided by 25 into your calculator, which should give you 1.8. Then to work out the volume for copper, you do 1.8 times 22, and 1.8 times 22 should give you an answer of 39.6. And then for tin, you do 1.8 times 3, which should give an answer of 5.4. So we know that that is their volumes. So now for copper's mass, so looking at the formula triangle, the mass of copper is density times volume. And so because we know that for copper, the density is 8.96, volume is 39.6. So multiply those two numbers together in your calculator, you should get an answer of 354.816, and then we're going to do the same for tin. So the mass of tin, so its density, which is 7.31 times 5.4. Put that into your calculator, you should get an answer of 39.6 39.474. Add those two numbers together. That should give you an answer. So 39.474 to add 554.816. That gives you an answer of 394.29. And then because we know mass is in grams, so that should be your final answer. Or you can also leave it as and round it to one decimal place. It's 394.3 grams. Either way, you would get the marks. So I'm just writing it properly here. Okay, having a look at question 16. So question 16 is cumulative frequency. I have a video on that in the description box down below. And basically it wants us to estimate the median mass of the apples. So we know to work out median from cumulative frequency graph, median is 50%. I'm going to rewrite that again. Median is equal to 50% of your total cumulative frequency. So our total cumulative frequency is the highest value, which is 50. So if you work out what 50% of 50 is, aka you could do 50 over 100 times 50, or you could just do 50 times by 0.5, or you could do 50 times by, divided by 2. They would all give you the same answer of 25. So we know the median is 25. So median. So then what we're going to do is draw a line across until it hits the graph and then draw a line down. We know that's hitting at a value of around 106 grams. And then if we go on to part B, I'll zoom out so you can still see the graph. So part B says estimate the proportion of apples that have a mass greater than 105 grams. Correction, 115 grams. So we're going to draw a line up from 115 and where it hits the graph and here, and then draw across. So that is hitting at around 42. So then up from 0 to that 42 mark, that is 42. But we know the maximum cumulative frequency is 50. So to work out the remainder, you would do 50 minus 42. Because remember, those greater with the mass would cover this range. So then if you put into your calculator or work out in your head 50 minus 42, you should get an answer of 8. Okay, going on to question 17. So question 17 says A is a prime number and B is an even number. Then it's given this formula and it wants us to circle the correct statement about n. So we know most of the prime numbers are odd. So examples are 3, 1, 3. Well, 1 is a questionable one that people debate about, so I'll pick other ones, such as a 3, 7, 11, and so on. And the only even prime number is 2. And so if it was an odd number, so I'll pick 3 for instance. So 3 squared would be 9. And then 9 plus, I don't know, I'll pick another random even number of 2, because 2 is the nicest even number. So 9 plus 2 times 3, so 2 times 3 is 6. So then 9 plus 6 would be 15. Okay, so it could be 15. But, it could be even, because we know 15 is an odd number. And 15 is not a prime number, so therefore we know it's not going to be always prime. So it could potentially be this, this, this. So let's have a look. If we picked 2 as our prime number, so 2 squared is 4. And then again, if we picked, another even number like 4, so 4 plus 2 times 4, so 2 times 4 is 8, 4 plus 8 is 12. So then 12 is an even number, but we know it's not always even because when we worked it out with 3, we got 15, and when we worked it out with 2, we got 12. So it can't always be even, it can't always be odd, so we know it can be even or odd. So just using examples are really good in terms of questions like this where you have to circle the correct statement. So number 18 says a bag contains 20 discs. So you've got 10 red, 7 blue, and 3 green. So Marnie takes a disc at random before putting it back in the bag, and then Nick takes a disc at random before putting it back in the bag. And then Ollie then takes a disc at random. So it wants us to work out the probability that they all take out a red disc. So if it's a case of them just all taking out a red, then we know that there are 10 reds, right? And out of 20 discs. So 10 out of 20, if you can even simplify that, that's a half. So if we know that the chance of taking out a red is a half, and for the probability of all of them taking out a red, that would be a half times a half times a half. And you can put that into your calculator or work it out. So times all the numerators, that's 1. All the denominators, that's 8. So the probability of them taking out all 3 reds is 1 out of 8. Then if we look at part B, it says all 20 discs are in the bag. So it says Reggie takes 3 discs at random, one after the other. After he takes a disc, he does not put it back in the bag. The difference between here is that they put them back in the bag, whereas Reggie does not put them back in the bag. So it says Reggie's first disc is blue. So it says work out the probability that all 3 discs are different colors. So I'm working out the probability of picking out 3 different colors. So in order to do that, so we need to think of the different possible combinations. So it says his first disc is blue. So if I scroll up, actually I'll just zoom out so you can see both. So it says that the different colors are blue, red, and green. Probability, so there's 7 blues, 10 reds, 3 greens. Now after I've written that information down, I'm gonna zoom in so you guys can see clearly. So having a look at question 18. So we know that the first one is a blue. So then we definitely know the first one will always be a 7 out of 20 probability. Now, what can vary is the different combinations. So let's say if it could either go blue, red, then green, or it can go blue, green, then red. They are the only 2 possible combinations. So then if he picks out blue first, a red second without putting it back would be 10 out of 19. And then a green without putting it back would be 3 out of 18. And the reason why it's reducing each time because he's not putting it back. You've always got 1 less each time. Then again, the blue first is 7 out of 20. But then a green second would be 3 out of 19. And then the red third would be 10 out of 18. So now if you worked out all these different combinations in your calculator, and then if you were to add them all together, that would give you an answer of, so work these all out and then add them all together. Simplified fraction in your calculator would be 10 out of 57, or you can leave it as a decimal place. Either way, you would get the marks. So then if we have a look at question 19, it says there are 4 starters and 10 main courses to choose from. So it says 2 of the starters and 3 of the main courses are suitable for vegans. So what percentage of possible lunches have both courses suitable for vegans? So we know that there are 4 starters and 2 out of the 4 are suitable for vegans. So that would be, for the starters, the fraction is 2 out of 4. And for the main courses, 3 out of the 10 are suitable for vegans. So that'll be a fraction of 3 out of 10. And then for both, so whenever you've got 2 probabilities, when you're trying to work out the likelihood of them both occurring, you multiply them because it's like your A and your B. So you multiply them together. So then multiply the 2 denominators, 2 numerators are 6, 2 denominators are 40. So now we've got a fraction of 6 out of 40, but because it wants it as a percentage, we're going to work out in our calculator 6 divided by 40 times by 100. And if I work that out now, that should give you an answer of 15%. So having a look at question 20. So question 20 says n is a positive integer, and it wants us to prove algebraically that this equation is a cube number. So in order for us to do that, we literally are going to need to expand this expression. So let's look at the first set of brackets. So it says 2n squared times 3 over n. So that would be 6n squared over n. And then 2n squared times n, that would be 2n cubed. So that's added to 6n times n squared, which is 6n cubed, and then 6n times minus 1, which is minus 6n. So now we're going to simplify and collect the like terms. So we're going to collect our cubes together. So that would make 8n cubed. And then we've got 6n squared over n, so then that would end up dividing, leaving us with 6n. So now we've got 6n minus 6n, and if you did 6n minus 6n, you get 0. They're going to end up cancelling each other out. So then we're only left with 8n cubed. And so because we are left with 8n cubed, 8n cubed is a cube number. And why can we say that? Because we know if we worked out the cube root of 8, you get 2 if you put that in your calculator. So essentially, 8n cubed is the same as saying 2n cubed. So therefore, it is a cube number. Okay. Let's have a look at question 21. So it says, y is inversely proportional to the root of x. It's given us values for y and x, and it wants us to work out an equation connecting them. So in terms of inverse proportionality, I have a way of writing this down. So to write down the formula, it would be y, wherever it says is, that's equivalent to our equal sign. If it says inversely proportional, then our constant k would be above what it's inversely proportional to, because it will be divided by that. So it's inversely proportional to root of x, so that's how we write it. So now to work out what our constant k is, we're going to substitute our value of y is 4 and x is 9. So then 4 is equal to k over the root of 9. We know the square root of 9 is 3. So then to work out what k is, we're going to rearrange this. And so if you multiplied both sides by 3, you would work out that k is equal to 4 times 3, which is 12. So now we know what k is. In order to work out what the complete equation will now be, it would just literally be y, rather than y is equal to k over root x, it will be y is equal to 12 over root x. And that is the complete formula. Then it now says work out the value of y when x is 25. So literally we're just going to substitute x is 25 into the formula. So it will be y is equal to 12 over root 25. Root 25 is 5. So it'll be y is equal to 12 over 5. So then now working that out, you could either leave your answer as literally 12 over 5, the mark scheme allows that, or you can put that into your calculator and that would give you an answer as a decimal of 2.4. Either way is fine. So now if we go and have a look at question 22, it says simplify fully this. So what we have is we've got x to the power of 5 minus 4x cubed over 3x minus 6. So in terms of simplifying this, there's a few ways that we can do this. So first thing is we can factorize the denominator. So if we've got 3x minus 6, that could be factorized. So the common factor is 3. So that would, if you divide them both by 3, so 3x divided by 3 would be x, minus 6 divided by 3 is minus 2. So that's now denominator factorized. So we can write that as x to the power of 5 minus 4 x cubed over 3 bracket x minus 2. So now we need to factorize the top. So we can see that common factor is x. So if you have x to the power of 5 minus 4x cubed. So x is the common factor, so bring x out. So that's going to change it to x to the power of 4 minus 4x squared. Okay, so now that we have this scenario here, we can, the whole point is that our denominator has x to the minus 2. So we want to make sure that our numerator has at least one of those brackets as well to simplify it. So other than writing it out like this, we can also factorize that even further. So that would end up being x, and then again, x is a common factor between them. So x cubed minus 4x equals that, and then the two x's on the outside can multiply. So that leaves us with x squared. And again, we can simplify this even further. Again, x is their common factor, so that'll be the x squared, x squared minus 4. Okay, so this one is now nicer. So again, the x squared and the x will multiply, so that will be x cubed bracket x squared minus 4. So that is what we have simplified our top bracket to. But again, we still can't see the x minus 2. But what we do have is that we have x squared minus 4. And we do know that x squared minus 4 is the same as writing out x minus 2 and x plus 2. So then now we have x minus 2, the x cubed on the outside. I'm just rewriting what we have so far. So we've got that over 3 bracket x minus 2. Okay, so now the x minus 2 is, and that's going to leave us with an answer of x cubed bracket x plus 2 over 3. And this is only just one of the ways that the mark scheme allowed in terms of writing your answer. So this is just one of the methods. Okay, so let's move on. So having a look at question 23. Question 23 says that we have PQR is a straight line, and it says it's given us a ratio of P to Q, which is 3, and Q to R, which is 1, and it says that PQ with the arrow on top is a vector. So the vector PQ is represented as A. So it wants us to circle the vector for RQ. Okay, so if we know that the ratio is 3 to 1, then in terms of writing out QR in terms of A, it's the same as saying A over 3. So then, or another way of writing that is a third of A. So because we know it's a third of A, but now we're writing the vector for Q to R, it's going to be negative a third of A because it's going in the opposite direction to QR. So it's going to be minus a third A. And the only one that's closest to that is this one. So having a look at question 24, it says here is a sketch of y equals f of x. F of x just means a function of a graph. So y is equal to f of x. And it's given us the curve and the points that it passes through. So let me just zoom out to see what it says. So it says on the grid, sketch the curve y is equal to f of x plus 2. So if we have a look at this f of x plus 2, what that basically means is that it is now being translated, right? So what is being translated is in the x direction. And usually whatever happens in the x direction in the brackets is opposite to what actually happens. So if it says x plus 2 in the brackets, then it's actually shifted minus 2 in the x direction. And we know that there's no number change to the y, so the only change is going to be to the x. So if I zoom out to actually see the graph, so what we're going to do is we're going to use the points that they've given us to help us work this out. So if we have a look at the first point, again, I'll zoom into the points. So because basically we're going to take away 2 from all the x values, so this one would change to minus 4, 10, minus 3, minus 3. So all the y's are not going to change. So minus 2, minus 2. This one would be minus 1, and then 0, 6. And then now I'm going to plot these new points on the graph. So the first one was minus 4. Oh, I forgot the minus in front of the 10. So minus 4, minus 10. So I'm going to find that on the graph, which is here. Then it was minus 3, minus 3. Then it was minus 2, minus 2. Minus 1, minus 1. And then 0, 6. So then now I'm going to draw the graph. And that is how we would answer this question. Okay. So let's go down to question 25. So question 25 says, work out the size of angle x. It's given us a right angle triangle and it's given us another triangle as well that is not right angle. So in terms of working out our angle x, what we can do is, the first thing that we're going to do is we are going to work out what this missing length is here. So at least because both of these triangles both share that line. So we can use the right angle triangle to help work out that length. And because the right angle triangle has a right angle and another angle, we're going to work out that missing length, not using Pythagoras, but using SOHCAHTOA. So first of all, we're going to label our SOHCAHTOA. So then this is the adjacent, hypotenuse, and O are opposite. So then out of our SOHCAHTOA, we've been given our A and we're working out our O, so we're going to be using TOA, which is tan. So it'll be tan 49, because that's the angle, is equal to our opposite, which we don't know, over our adjacent, which is 16. Rearrange that to be 16 times tan 49. That should give you an answer of 18.41. So then now we've got that is our length. So we know that that side is 18.41. We also have another length and we have two angles. So I have a video on sine rule and cosine rule. So whenever you have two angles and two lengths of an angle that's not a right angle, you would be using sine rule. So sine rule. Okay, so sine rule is A over sine A is equal to B over sine C, sine B, and then obviously you'd have to C over sine C, but again, I did mention in my video that you would just focus on the first part of that. So then remember the A's are going to be so the little caps, the lengths, so let's say if I call this little A, little B, and then the angle opposite that line, so angle opposite line A is here, so that's capital A. Angle opposite line B is here. So now I'm going to substitute those values now that I've labelled. So that's going to be 20 over sine 35 is equal to 18.41 over sine x. So now I'm going to rearrange to make sine x the subject. That's going to give me 20 over sine 35 times 18.41. So now that we've worked that out, to put that all in your calculator, and then for a value for x, you should end up with an answer of, so bear in mind for x, you need to work out the inverse sine of all of that. Because remember, whenever you work out the angles, you always do inverse. Put that all in, and then you should come up with an answer of x being to three significant figures, 31.8 centimeters. Sorry, not centimeters, because it's not a length, it's angle. Degree. So, having a look at question 26. So, question 26 now has given us a function of x over x plus 2. And it says work out f g x. So, this is all to do with composite functions. So, it says give our answer to a plus b x to the power of n. So, when it comes to composite functions, so at the moment with f of x, you've got x there. But because you've got f g of x, it's basically going to change where, rather than having the x's in the formula, you're going to have the g of x there. So you're going to replace all your x's with the formula for g of x. So the numerator is now going to change to x squared minus 2, because it's going to end up being the same as g of x. So this is basically what's going to be. It's going to be g of x over g of x plus 2 rather than x. So now I'm replacing it with the actual equation of g of x. So then it's going to be x squared minus 2 plus 2. So now to simplify all of this, it's going to be x squared minus 2 over x squared. So minus 2 plus 2 cancels out to make 0. So that's just all going to be over x squared. And then last but not least, now that you've worked that bit out, you can simplify this even further. That's the same as saying x squared over x squared minus 2 over x squared. X squared over x squared is going to cancel out and give us 1. 2 over x squared is going to give us an answer of minus 2x to the power of minus 2, because whenever you divide over an indice, it becomes a negative power. So this is how we would write it. And this is good because this is the format that it wants us in. So then now looking at the format that it wants us in, we can happily say that our value of A is equal to 1 and then B is equal to minus 2. So yeah, leaving it like this is fine as well. You wouldn't have to write what A or B is because they would allow that in the mark scheme. So then having a look at question 27. So question 27 says the point 1 over 64 lies on the curve y equals x to the k to the power of x. So what's this just show that the point half lies on the curve. So in order to support this statement, we need to work out what k is. So by doing that, we're going to substitute the point that we have up here. So then our y value is equal to 1 over 64 is equal to k to the power of 3. So to work out what k is, we're going to work out the cube root of 1 over 64. Put that into your calculator, or you can work it out. That would be a quarter. So we know k is equal to a quarter. So essentially, it's y is equal to a quarter x. So now to support whether to show that this point lies on it, again, we're going to substitute half for y and a half for x. So then a half would be equal to a quarter to the power of a half. We know that to the power of a half, based on our indices, negative indices and fractional indices, so anything to the power of a half is equal to the square root. So then saying a quarter to the power of a half is saying the same as the square root of a quarter. So a square root of a quarter into your calculator would be equal to a half. So we can therefore say that, therefore, this point does lie on the curve. So having a look at question 28, it says Izzy runs an 80-meter race in 14 seconds, and then it basically shows her speed for the first 6 seconds, which was increasingly constant, and then for the next 8 seconds, which was constant but a different constant rate. So in order to work out the acceleration, we know acceleration is change in speed over time. So it says here that at the end of the 14 seconds, it's 2 meters per second more. So we know the change in speed is 2. And the total time that they're working out the acceleration for is for 8 seconds. So it'll be 2 out of 8, which would be a quarter. So you could either work it out as a quarter meters per second, remember to the -2 for acceleration, or you could write your answer as the decimal of that, which is 0.25 meters per second squared. So that's that. And then the last question of this paper is, it says that Izzy finishes the 80-meter race with a speed of v meters per second. So it wants us to work out what v is. So I'm going to go back to where the graph is in order for us to work this out. So let's say if we call the speed here at 6 meters per second x, it says that at 14 seconds, her speed is 2 meters per second more. So let's just say here at 14 meters per second, we're going to call that speed x plus 2. So we know that on a speed time graph, the distance is the area underneath the curve. So we're going to work out the area of this right angle triangle, which that formula is half base times height, and the area of this trapezium formed, which is half bracket a plus b times height. So let's look at the right angle triangle first. So it's going to be a half times 6 times the height, which we don't know, we just called it x. So half times 6 times x, which would give you an answer of 3x. And then if we look at the area of the trapezium, it's going to be a half, and then your a plus b are the two parallel lines in the trapezium. So that's going to be our x plus 2, and then our height is going to be the difference between the 14 and 6, which was 8 seconds. So then half times 8, which is 4. Simplify inside the bracket, so x plus x, which is 2x, and then plus 2. Then we can expand that out, which would leave us with the area of the trapezium being 8x plus 8. So then adding the area with the triangle plus the area with the trapezium, that's equal to our total distance, which is 80 meters per second, as we were told already up above what the distance is here. So then that would be 11x plus 8 is equal to 80. So then now we're going to rearrange to work out what x is. So I'm just going to write it up and write it on this side here. So then take away 8 on both sides. That would be 11x is equal to 72. Divide by 11 on both sides. That would be 72 over 11. And you can use your calculator in order to work this out, or you can leave it as a fraction as it already is. So just putting it into the calculator, you should get something like 6.54 ... which can round to 6.55. And then remember, v is equal to x plus 2. So we need to add 2 to this, and that should give you an answer of 8.55. Or you could have left it in a fraction format of 94 over 11. Either way is fine. So we know that the final answer is 8.55 meters per second minus 1. Thank you guys for watching. I hope this was useful for you if you are sitting the AQA paper or if you're revising this question, and stay tuned for more content.